This is section 4.4 in Precalculus. And this is all about the exponential and log applications. You may have seen this in Algebra 2, but we're going to go back through it this year also. And I'm sorry about that noise in the background. I'm actually sitting in front of the fireplace and I don't want to move, so you might have to put up with it. Sorry about that. So basically there's two formulas that you need to know. If you deposit P dollars into a bank account paying an annual interest rate, and R is expressed as a decimal, it's compounded N times per year, then the amount you owe after 2 years is this. So basically this is the formula for compound interest. And so basically you just need to identify each of the variables, okay? So P is the amount you deposit. P stands for the principal. And then R is obviously the rate. That's going to be the percent. The N represents how many times it's compounded per year. So like, for example, it might say that it's compounded quarterly, right? So that would mean 4 times per year. Or it might say that it's compounded monthly. That would mean that it's 12 times per year. And there are other options. And then A is the amount that you would have. So that's your ending amount of money. And then T is always expressed in years. Okay. So there's that one formula. But notice the second formula. It says if you deposit P dollars, so that starts exactly the same. So P for principal. Still paying an annual interest rate of R. So that's exactly the same. No different yet. The difference is right here, and I'll kind of highlight it because it says compounded continuously. So if it says it's compounded continuously, in that case, there is no N. And so that's why you have this E. Now, E is not a variable. E is the constant 2.718 kind of thing, the exponential term. All right. And then A is still the amount that you end up with. So the only thing you have to decide is which formula should I use? And it's going to all be based on whether it says compounded continuously or if it gives you a specific timeline for compounding, quarterly, monthly, whatever. Okay. So when I read number 1, it says, how much would you have after 5 years? So I've got my T. If you invested $5,000, so I've got my P, because remember P is your beginning amount, interest rate of 5.5%. So remember you have to put this in as a decimal. So move the decimal 2 places to the left. So it's going to be 0.055. And then because it says compounded monthly, that means it's the first equation where you have the N equal to 12. So I'm going to write that first equation. A equals P is 5,000. 1 plus R is 0.055 over N, which we know is 12. The whole thing is raised to the NT, so to the 12 times 5. Okay. So in these problems, I want to see the setup for the equation so that I know that you understand where everything goes. But in this particular case, in order to solve, notice what I'm solving for is A, it's already by itself. So I could literally just put all of this into my calculator in one step. So on my calculator, and these will all be calculator problems, I'm just going to type in exactly what I see underlined, 5,000. And then in parentheses, I'm going to put 1 plus, and then I have a fraction. And that fraction is 0.055 over 12, and then close that big old parenthesis, and then that whole thing has an exponent of, you can either type in 12 times 5 all in the exponent, or you could just do the multiplication yourself and say, to the 60, however you want to do that, and then enter. And so that's the amount. Now, whatever answer you get, see if it seems reasonable. So if you invest $5,000, is it reasonable that after 5 years, you might end up with $6,500. Yeah, that is reasonable. And since this is money, we're going to round it to 2 decimal places. So we're going to say 65, 78, 52. 65, 78, 52 is how much money you would end up with. Okay, so read the next one. How much would you have after 5 years? So T is 5. If you invest 8,000, so P is 8,000 at a rate of 6%, so R is 0.06, compounded continuously. So because it says continuously, that's how you know you're going to use this second formula. So A is what we're trying to figure out, equals, P is the amount you start with, 8,000. Then the E stays because the E is that exponential number, that 2.7 number. And this is raised to the R times T. So to the 0.06 times 5. And again, since we're trying to solve for A, and I've already got everything right here on the right side, I can just put that straight into my calculator the way I see it. So I'm just going to type in 8,000. And then E is, I can do second ln E, and it automatically pops up with an exponent. And I want the exponent to be 0.06 times 5. And notice I've got all of that in the exponent, equals. So in this case, we start with 8,000. And this time, after 5 years, we end up with 10,700. So I'm going to say 10,798.87. 10,798.87. Okay, so look at number 3. So find the amount you would have to invest. Okay, the amount you would have to invest means you're trying to find the P, right? The principal. 8.5%. So R is 0.085. This time, notice it says compounded quarterly, which tells me I'm going to use the first equation because that's the one that has the N. And in place of N, I'll put in a 4 for quarterly. And I want to end up with 100,000. That means the A, the amount I end up with, is going to be 100,000 after 40 years. So T is 40. So just set up your equation. A equals, so 100,000 equals, P is what we're trying to find, 1 plus R 0.085, R over N, all raised to the NT, so 4 times 40. Okay, so this time, in order to solve, I've got to get that P by itself. So there's different ways to do this. I think what I'll do is, I think I'll go to my calculator and figure out what this number is, what that whole thing is. And then whatever number that is, if I want to solve for P, wouldn't I just divide 100,000 by that number? So let's see, I'm going to put into my calculator that whole thing. So I'm going to put parenthesis 1 plus the fraction 0.085 over 4. And then that is raised to the, I'm just going to type in 160. And so that whole thing I have in green is this 28.9155. And instead of writing that down, and instead of rounding that number, looking at the equation, if I want to solve for P, basically I just need to divide 100,000 by that number. So I'm just going to, in my calculator, I'm going to do a copy and paste. I'm going to say 100,000 divided by, and notice I'm just going to move my cursor up to that number and press enter so that it'll pop that whole thing down there. It's not rounded at all. And I get 3458.35. Let's see. So P equals 3458.35. And let's see if this makes sense. P is the principal. So if I start with $3,400, then after 40 years, I'm going to end up with 100,000. It seems outrageous, but time is the key factor here. The longer you can leave it set, the more it's going to grow because it starts growing faster at the end. Okay, let's see. Okay, so let's try another one. Now, actually, you might be tempted to think, oh, I got it, but the last few are a little bit harder to solve, so make sure you hang in there for those. All right, so number 4, how long will it take? Okay, so I'm trying to find T. How long will it take to double your investment if you invest 6,000? So if I'm investing 6,000, that's my P, and I want to end up with 12,000. So that means my A is 12,000. Let's see, into an account that pays 8.5%. So R is 0.0825. Compounded monthly. So because I know my N is 12, that means I'm using the first equation. All right, so let's set it up. A equals, so 12,000 equals P 6,000 times parentheses 1 plus R over N, so 0.0825 over 12 raised to the N T. And remember, T is what we don't know. Okay, so here's the thing. In order to get the T out of the exponent, this is kind of like having a 5 to the X. I'm going to have to eventually change it to log form. But before I do, I want to get that exponential part by itself. So here's what I'm going to do. I'm going to, first of all, divide by that 6,000 so that all I have on the other side is 2. Okay? And then I'm going to figure out what this parenthesis is in my calculator. So I'm going to go ahead and do that. So in my calculator, I'm going to put in 1 plus, and then I want the fraction 0.0825 over 12. Okay, so that parenthesis is this 1 point. Now, whatever you do, do not round that because you're going to be tempted to round it to just 1. And it's going to make a big difference if you use 1 versus if you use 1.006. And it'll even make a bigger difference now if you also use 1.006875. So it's really important on these problems to not round it all until the very end. Until you get to the answer, try not to round at all. So I'm going to leave that whole thing as 1.006875. So in the parenthesis, I have 1.006875. And I'm only writing it down for your sake. It's still to the 12t. You wouldn't necessarily have to write this down because you have it in your calculator. It's not 2 times that. It's 2 equals this, right? Because 2's on the other side when I divide it by 6,000. And then I have that parenthesis to the 12t. All right. So now I have the exponential part by itself. Now I can change it to log. So I'm going to say log base, that whole parenthesis, base 1.006875 of 2 equals the exponent of 12t. So I'm going to put that log into my calculator, and then whatever that log base 1 point blah, blah, blah of 2 is, then I'm going to divide the whole thing by 12, and that'll be my t. So I'm going to type it in this way. Let me move it over here so you can kind of see the equation while I'm typing it in. Whoops. That's not what I wanted to do. Just a second. Sorry about that. Okay. So here we go. I'm going to type in log. So remember, you go to alpha window. So that's number 5. I want log. And then instead of typing that whole number, 1.006, if you want to, you can go up and do a copy and paste. So that's going to go in there. And then of 2. And that whole thing comes out to be this. And then remember, to solve for t, I'm just going to divide that by 12. So t equals 8.43. If I'm rounding to 3 decimal places, it's going to be 8.431. So t equals 8.431. And so what that means is after essentially 8.5 years, the 6,000 is going to double. That's not too bad. You're not doing anything. I know 8 years is still a long time, but you're not doing anything, and literally you're doubling your money. Okay. So that goes up here with number 4. Let me squeeze this up a little bit. So it looks like it all goes up there. Okay. So let's look at number 5. Find the time required. So this could be another one of those where we're solving for t. Find the time required. So we're solving for t. For an investment of 20,000, so P is 20,000, to reach 50,000, so the ending amount is 50,000. Interest rate is 0.08, compounded continuously. Okay, so there it is. It's compounded continuously, so I know I'm using that second equation because there is no n number. Okay, so I'm going to say A equals, so 50,000 equals P, 20,000, times e to the RT, so to the 0.08 t. Okay, and so in order to solve, remember, it's an exponential equation, so eventually I'm going to change it to log, but first I need to get this exponential part by itself. So I'll divide by 20,000, and if I do 50 divided by 20,000, let's see, that's going to be 5 halves. So basically it's going to come out to be 2.5 equals e to the 0.08 t. Okay, now I can change it to log. And since it's a base e, I'm going to say natural log of the answer equals the exponent. So in order to solve for t, I just need to figure out what the natural log of 2.5 is and divide by 0.08. So natural log of 2.5, natural log of 2.5, close that parenthesis, see what you get, and then you can divide by your 0.08. So in this case, t is essentially 11 and a half years, 11.454. Now, before you cut off the video, just something I want to let you know. I've been writing down, and this is just because it's the video for informational purposes, but I've been writing down all of the given information. So like up here on number 1, I wrote out what N is and what T is and what P is and what R is. And that's fine if you need that to help you. But basically what I need from you as far as showing your work is the equation. I just need the setup. That's all I really need is that, I mean, obviously I want the answer also, but if you show me the equation setup, then I'll know that you knew to use the correct equation. And then any of the solving stuff that you do, you can write down if it helps. But since you're using your calculator, that's fine to keep it all in your calculator, as long as I can see the equation setup along with each answer. Okay, and that is section 4.4.